Okay, these are some more problems from section 4.3, and this is number 2. And we just want to find the relative extrema, so what we do is we take the first derivative. So this was our function, negative 2x to the third plus 6x squared minus 3. So if I take the derivative, it's going to be minus 6x squared plus 12x. And it's either equal to 0 or undefined. It's not undefined, it's just a polynomial, so it's equal to 0. I set it equal to 0, and I can factor out negative 6x, so when x is 0 or when x is 2, the derivative is 0. Those are my critical values, so I put these in. All right, 0 and 2. And I tried some values when x is negative 1. The derivative, if I put a negative 1 in here, that's going to be negative times negative is positive, so it's positive. And that's going to be negative 1, negative 2 is negative, so it's going to be negative. And then that was less than 0. If I put 1 in here, that's negative, and that's negative, so a negative times a negative is a positive. And if I put 3 in here, this is positive, and that's negative, so it's negative. So see, we have sign changes. So I have things happening at 2 and 0. If I put 0 in the original function, I get negative 3. So that's one of my points, one of my relative extrema. Then if I put 2 in the function, I put it on over here. Negative 2 times 2 cubed plus 6 times 2 squared minus 3. And then we just simplify that. 2 cubed is 8, 2 times 8 is 16, 4, 6 times 4 is 24. That ends up being 5. So this is my other point. So these are the y values that go with the critical numbers there. So 2, 5 is a relative maximum. 2, 5 is a relative maximum because y prime changes from positive to negative there. And 0, negative 3 is a relative minimum because y prime changes from negative to positive there. 0, negative 3. Okay? So that was pretty easy. And you can always pause that and take a look at it if I'm going too fast here. Let's take a look at number 10. And number 10, we just wanted to determine the intervals in which the function is concave up or concave down. So we take the second derivative. So first of all, we take the first derivative, which is going to be negative 1/3 x to the minus 2/3. And then I take the second derivative. A negative times a negative is a positive. 2 over 9. X to the negative 2/3 minus 3/3 is minus 5/3. Up there it should be 5/3. Pardon me. That's a little error. 5/3 and 5/3. Let me fix that. I don't know why I wrote 5/9. I just carried that 9 over, so that should be 5/3. Excuse me. 5/3 and 5/3. It really doesn't matter because they're both odd anyway, but let's fix that. Okay, so that's 5/3, 5/3. And I put it down the bottom, so it's positive exponent. And then it's not going to be equal to 0 because the top's never 0. But let's see, when the bottom is 0, it will be undefined. So that's when x is 0. So x is 0 is my point of inflection. And I check this. I tried negative 1. If I put negative 1 into this, this is positive. That's negative. If I put positive 1, y prime of positive 1, I get positive. I didn't write that down. Double prime, pardon me, of positive 1 is positive. So there you go. And that's all we have. So basically we are concave up. Concave up when this is positive. I'm sorry, when this is negative. Sorry, when it's positive, it's concave up. Smiley face. So it's concave up from 0 to infinity, and it's concave down from negative infinity to 0. Okay? And remember this is negative 5/3 and 5/3. Okay, sorry about that faux pas.